Hello class, and welcome to our Chapter 1 final review. So first thing that we're going to look at is GCF and LCM. So what does GCF stand for? Exactly, it stands for the greatest common factor. And a fact about the greatest common factor is it is always less than or equal to our smallest number. So our greatest common factor cannot be bigger than the smallest number we have. What about LCM? What does LCM mean? Yes, it means least common multiple. And in the reverse sense, this one is always bigger than our biggest number. It's interesting. I can remember it because it's smaller than our smallest and bigger than our biggest, but it's a little complicated because how is our greatest smaller and our least bigger? But it's like that because we want to get the least to be as close to that big number as possible. We want to get the greatest to be as close to that smallest number as possible, but it can't go over and it can't go under. So let's look at some examples. 6, 12, and 26. The best way to find what the greatest common factor of a number is to look at the smallest number because we know it has to be smaller. So let's look at 6. Our factors of 6 are 1 and 6 and 2 and 3. You want to write down all of the factors, even the 1 and 6, and you want to write them down in this nice order where we're going ascending, 1, 2, as such. And then here, we are the closest we can possibly get between two numbers. So we know we're finished. Now let's think. Does 6 go into 12? Yes. Does 3 go into 12? Yes. Does 2 go into 12? Yes. Does 1 go into 12? Yes. So far that works with 12. All of those work. So let's try 26 now. Let's think of our factors of 26. Can 6 go into 26? No, it can't, because 6 goes into 24. Now we know it's even, so we have it there. What about 3? Can 3 go in? No, it can't. So we see these, and we don't even need to go any more with these, because the biggest number we have is 2. 26 cannot work with 6. 26 cannot work with 3. So their greatest common factor is 2. Let's look at this one. 9, 12, and 18. Again, I care about the factors of 9 first, my smallest. I got 1 and 9, 3 and 3. It's not even, so I can't have 2. Let's think about it. Can 9 go into 12? No, it cannot. Can 3 go into 12? Yeah, perfect. So let's start with that 3. Can 3 go into 18? Yes! So 3 is our greatest common factor. But now let's look at it differently. I want to look for our least common multiple. The multiples are the opposite. We take these, and essentially, these now will be our factors. They used to be our multiples, and we were finding the factors, but now these are our factors, and we're finding the multiples. So it has to be greater than or equal to 20 in this first case. Let's look at our multiples. All we do is fill it out. 6, 12, 18, 24, 30, 36. We got 42. I'm just going to keep going until I get to something I think might be accurate. Because let's do this if we had 20, 40, 60. We know it has to end in a 0. 80. So I'm going to keep going. 30 didn't work. 42, 48, 54, 60. Hey, there's a 60. 12, 24, 36, 48, 60. Excellent! So, we need one that all three of them have in common. Even though this has 12 and this has 12, no 12 here. Even though this has 36 and this has 36, this has 24 and this has 24, no! We can't do that. We have to find the smallest number they all have in common. And the smallest number is 60. So we find out our smallest number they all have in common is 60. Let's look back at the other one. Let's look at our 9, 12, and 18 column. So if we're looking at this, let's do our multiples. 9, 18, 27, 36, 45, 54. I'm going to stop there just because I can't fit it anymore. 12, 24, 36, 48, 60, 18, 36. Hey, look at that. Our smallest number they have in common is 36. So that's their least common multiple, because now we're just multiplying times 1, 2, 3, 4, whatever we're doing. So that's what we do. That's how we find it. What about in this case? Here we have 7, 9, and 10. So let's find our greatest common factor. First, 7, our factors are 1 and 7. Do we have any others? No, 7 is prime. Now let's look at this. Does 7 go into 9? No. Does 7 go into 10? No. So I'm getting these different answers. I'm getting none or 1. Let's think about it. Here, I've got 9 and I've got 10. My factors of 9, 1 and 9, 3 and 3. My factors of 10, 1 and 10, 2 and 5. Here, I checked to see if there's anything else. Between them is 3 and 4. 10 is not divisible by 3 or 4, so I've reached the end of my factors. Do they have any number in common? They do. It's this number 1. Even though that's the only number they have in common, they still all share that number. They still all share it. It is impossible to not have a greatest common factor. It is impossible to not have a least common multiple. You always have one, whether or not it be 1, whether or not it be anything else. So you'll always have one. Here's another fun fact. Prime numbers. The least common multiple, if we have a prime number, is always going to be the number times the number. So for example, 7 and 9, our least common multiple is 63, because there's a prime number. If we included that 10, it'd be 630. If we've got that prime number, there's no other way around it. The least common multiple is almost always, if not always, going to be the numbers multiplied together. So now let's look at this one. Here we're looking at ratios. So I want us to look at the ratio 2 different ways. The ratio of red to yellow and the ratio of yellow to red. You might think these are the same thing, but they're different. It's like writing your first name and your last name, or your last name then your first name. Everything, the information is all the same, but it's in a different order. So let's count. How many reds do we have? Perfect. We have 3. So I put them in the corresponding sections because it goes red first here and it goes red second here. And how many yellows do I have? Great. I have 6 yellows. But when we do this, I want it in simplest form. So I find the greatest common factors. Greatest common factor between 6 and 3 is 3. I divide each by 3. I get 1 to 3. Same thing here, my factors, but I get 3 to 1. So when we do this, you must carefully read the problem and see, is it asking you red to yellow, yellow to red? Is it asking you muffins to cupcakes, cupcakes to muffins? Because if you get the wrong ratio, if you put them in the wrong order, it is incorrect. Let's look at this one. This one we're doing rates. Very much the same. Joshua's cousin pledged $12 for a charity walk. So here's our walk. And he pledged for the whole walk $12. I'm doing a bad job doing that. He pledged $12. Joshua walked 3 miles. How much did his cousin pay per mile? So here's our 0 miles, here's our 3 miles. I'm going to split this up. It's 2, 1. How many different segments do we have? 3 different segments. And it asks us per mile. Per means each, and each means 1. So, per means each, which means 1. I have 12, and I need to split it into those 3 groups to make it even. So 12 divided by 3, we get $4 for each mile. And to check our work, we just do repeated addition. Because if I add up all the miles he walks, I should get the total amount. 4 plus 4 is 8, plus 4 is 12. So I know I'm correct. Let's look at this one. Another rate. Marcella divided 40.8 gallons of paint among 8 containers. How much paint is in each container? So I have 40 and 8/10, and I'm splitting it into 8 groups. All we need to do is divide. So let's look at this. I have to split this equally. When we do our division, we can just simply split 40 and 8/10. I put my decimal up there. 8 goes in 0 times here. It goes in 5 times here. That is indeed 40. I get 0. I bring down that 8. It goes in 1 time with 8, and I'm left with a 0 at the end and no more to bring down. So I find out that each gallon has 5 and 1/10 gallons of paint, because I split it evenly. And again, you can check your work by doing that repeated addition. So that's the way that you could check your work to make sure you get it in the end. Now I've got this. Who knows what this is called? This table. What kind of table is this? Yes, Fernando, it is indeed a ratio table. Excellent. So with our ratio tables, we need to figure out, we're trying to get an even amount of ratio. What that means is that if we simplified all of our fractions, they would be the exact same. Let's look at an example. Here I've got this ratio table. I want to go to my x. Just like a pirate, I want to get to my x. So I point my arrow to x. And what I do to the top, I do to the bottom. What I do to the bottom, I do to the top. So how do I get from 9 to 3? Using multiplication or division, because they are rates and ratios. So we use multiplication or division. Excellent. I divide by 3. And like I said, what I do to the top, I do to the bottom. So 27 divided by 3 is 9. So I get 9. But this one, can I go from 16 to 12 evenly? No, it does not work. So again, this is when I need to use my greatest common factors. So, what's the greatest common factor between 16 and 12? Yes, the answer is 4. And how did I go from 16 to 4? I divided by 4. What I do to the top, I do to the bottom. And I get 20. And now, how do I go from 4 to 12? I multiply by 3. So I do the same. So I get 60. And these are all equivalent ratios. And if I was to do my division, I'd check 16 divided by 80, 4 divided by 20, and 12 divided by 60. If we use our calculators, we get 2/10 for each of them, all the same, which is the same as 1/5. If I simplified, if I used my greatest common factors, I'd get down to that. So we know they're equal. Ratio tables must have equivalent fractions. Now, speaking of equivalent fractions, we need to tell if these are equal. So I want to see, are these fractions equal or are they not equal? Are the ratios equal or not equal? The way to do this is to simplify and get down to our smallest answer that we can. 12 and 30. What's their greatest common factor? Yes, it's 6. So I'm going to divide each by 6. 12 divided by 6 is 2. 30 divided by 6 is 5. Excellent. What about 48 and 120? Their greatest common factor is 24. Again, if you're having trouble, just do it by even. They're both even. Keep dividing by 2 until you get to the end. 48 divided by 24 is 2. 120 divided by 24 is 5. Hey, so we find out those are even. They're equal. What about this next one? 8/12. What's their greatest common factor? Yeah, their greatest common factor is 4. So I divide them each by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Let's solve this other one. What is their greatest common factor between 3 and 6? Yeah, it's 3. So I divide them both by 3. I get 1/2. Is 2 to 3 the same as 1 to 2? No, they are not the same. And we know they're not because they are in simplest form and they don't look the same. That's it. That is all of chapter 1.